Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on linear time invariant system analysis using is a transform. Empathy. Why analyze system using is a transform? It is used in real world signals, audio communication, biomedical signal processing, etc. Audio signals, it is used in audio processing and analysis of discrete time signal. Biomedical applications are used in analyzing and processing biomedical signals. System must be stable and causal. Z transform simplifies convolution that can perform the multiplication process. Industry relevance, DSP filters, control system and speech processing. See, DSP filters simplifies the filter designing and implementation with the help of IIR and FIR filters. Control system facilitates system stability and control. Speech processing enhance speech recognition and synthesis of discrete time signals and systems. Next, what do you want to analyze? From time domain, y of n is equal to x of n into h of n. From z transform, y of z is equal to x of z into h of z. Bridge between the time domain and the frequency domain. First, discrete time signal that can be converted to z domain, and then we can going to analyze the system, and finally we can apply the z domain from frequency domain representation. System behavior in z domain to find the causality and stability of the discrete time system. Next one, define LTI system. It is an efficient way to implement discrete time systems. The convolution of input sequence x of n and unit sample response h of n gives the output as y of n. Y of n is equal to summation k is equal to minus infinite to plus infinite x of k into h of n minus k. Next one, define LTI system. FIR systems, unit sample response h of n has finite number of terms. Y of n is equal to summation k is equal to 0 to m minus 1 h of k into x of n minus k. IIR systems, length of the impulse response h of n is infinite. Y of n is equal to summation k is equal to 0 to infinite h of k into x of n minus k. Next one, we can going to analyze with the help of discrete time signals. U of n is equal to 1 for n greater than or equal to 0, 0 for n less than 0. It is a positive value of all the independent variables of signals. That is nothing but U of n. Del of n can be represented as 1 for n is equal to 0, 0 for n should be not equal to 0. And unit ramp signal R of n is equal to n for n greater than or equal to 0, 0 for n less than 0. It is a linearly growing function. Next one is Z transform. Z transform is used for analysis of discrete time signals. It is very much useful in discrete time signals as well as system analysis. Z transform can be represented as h of z is equal to summation n is equal to minus infinite to plus infinite x of n into z power minus n. X of n and x of z forms the z transform pair. Next one, ideate part. We are going to analyze the system transfer function. System transfer function is the ratio of the output to the input. It is the mathematical representation of the system behavior. H of z is equal to y of z divided by x of z. Next one, frequency response. Output variation with input frequencies. System stability and performance for frequency response. H of omega is equal to y of omega divided by x of omega. Next one, ideate linear time invariant discrete time system. See, poles and zeros indicate system behavior and stability. ROC region of convergence determines convergence and causality, and going to evaluate using h of e power j omega. That is nothing but stability condition. ROC includes the unit circle. Next one, how to find the ROC of Z transform. X of Z is equal to Z divided by Z minus A when modulus of Z should be greater than or equal to modulus of A. It can be represented as 1 means the outside of the circle can be indicated by the ROC. See, next one, minus A2 plus A means less than 1 means the inside of the circle it represents the ROC. Next one, x of z is equal to z by z minus a when modulus of z should be less than modulus of a, means inside the unit circle defines the ROC of both the circles. Next circle indicates represent inner circle of the representation of one is nothing but ROC of the z modulus of z should be less than modulus of a with respect to real axis and imaginary axis. Next one, pole zero plot of linear time invariant dt system. It can be represented by real of z and imaginary of z. The value is for z where p of z is equal to 0. The complex frequencies makes the overall gain of the transfer function 0. Pole means the value for z where q of z is equal to 0. The complex frequencies that means the overall gain of the filter transfer function is infinite. Therefore, x of z is equal to p of z divided by q of z. Next one, how to find the impulse response of the system. First, from the difference equation, we can apply the reset transform and then find out the algebraic equation and then solving for roots. Finally, we can take the inverse reset transform. We can get the impulse response of the discrete time system. Next one, mind map. First, we can find the analytical exercise. Find the h of z and identify poles and zeros. Determine ROC and state the system stability. Find h of z for the given difference equation. Identify poles, zeros, ROC and check the system stability. Compute y of n for a given input x of n. It is used in digital filter design, speech recognition, echo cancellation, system reconstruction and compressions. Next one, we can see the assessment. Impulse response h of n has finite number of terms is called as FIR systems. Ratio of the output to the input is nothing but system transfer function. H of z is equal to y of z divided by x of z. Define difference equation. Difference equation can be defined as y of n is equal to summation k is equal to minus infinite to plus infinite x of k into h of n minus k. List the steps to find the impulse response of the linear time invariant dt system. First, for the difference equation, we can going to apply the z transform and then solving for roots and then algebraic equation and then finally we can take the inverse z transform. We can get the impulse response of the system. Z transform of unit step signal is defined as x of z is equal to z divided by z minus 1. List the applications of linear time invariant dt system. It is used in echo cancellation systems, noise cancellation systems, digital system designs, etc. Thank you.